Crazy. Nobody remind me. Yeah, I am crazy. Okay. Wow. It's a mess. Today is not a good day. Okay. Okay, let's switch into another topic. No, the same topic, but we try to cover some another applications of the double and triple integral, depending the region, no? Que es center of mass. Okay, suppose find the center of mass. Find the center of mass. Of the region, in this case 2D, there is double integral. The region 0 less than or equal y, less than or equal 1 minus x squared. Y I suppose que the density function es 1. Entonces, basically, si the density function is constant y es equal 1, the mass when you found pi, phi. Wow, this is too delayed. This is saying another problem. Oh, let me see. Here, right? Who asked me? Gerardo. Look at this view. Okay, I'm waiting. I got. Okay. Super. Let me redo. Boom. This is the beauty of this board. Okay, we have recovered the previous and the new information. Okay, now this is my goal now. Find the center of mass of the region formed by this. Entonces the density is given as 1. Entonces cuando the density is 1, entonces basically es because, okay, this is a laminar. It's 2 dimension, no solid. Now, when the integrand function is 1, entonces this is equivalent to say area. So es, you know, when the density function is 1, it's because the area and the mass is the same. Okay? Okay, let's do it now. Well, the formulas for the center of mass is, let me copy here quickly. It's my divided by m. M is the mass. And y hot is nx over m. And ny is double integral in the region, the corresponding region, x, multiplication by density function. Nx is the double integral and the mass, well, the mass is the mass. The mass is double integral in the region R without anything. Is considering that the integrand function is the density, and that's it. This is the formula to compute center of mass in 2D. Let's do it. Okay, so now my step number 1 is do the region. Fortunately, it's 2 dimension. Entonces, básica, ahí separé, bueno, y0 es the x-axis, and the y equal 1 minus x squared, es parábola, ¿no? Ese parábola. And this parabola up and down. Okay, it's a parabola, up and down. And 1 here is the vertex up and down. This is this equation. Okay, this equation, sorry. And this limit is, so, well, this point is the point 0,1. This point is the point 1, 0, and this point is the point -1, 0. Okay, now let's compute the everything. 3 integral, and finally division. Well, so I make a decision to perform the double integral, for example, in that direction first, and extending in this direction. When you are doing that, for example, m es de triple integral, de doble integral, sorry, the integrand function is 1. You integrate dy first because I select this order. I prefer this order. You know, sometimes it's impossible in this order, but I prefer, I don't know why my brain is easier to see that. So I go from 0 to the y of the parabola, que es 1 minus x squared. And you extending in both sides from -1 to +1. You can do that like that. Or you take advantage of the symmetry and you integrate from 0 to 1 and multiplication by 2. In this case, I prefer doing that way because, well, in this case, the integrand function is 1, que es even function. But when there's no even, entonces no multiplication by 2. Okay, you compare this, and the answer is 4/3. And this is the mass. I don't know si this is kilogram, pound, I don't know. I'm going to find mx or my first. Doesn't matter. It's again double integral, but the integrand function now is x. Density function is 1 dA, dy dx. And the limit is the same. It's from 0 to 1 minus x squared, from -1 to +1. In this case, look. In this case, the function, the integrand function is odd. And you know, in calculus 1, when you integrate odd function and interval is the same symmetric from -1 to 1 to -2 to 2 is 0. And make sense according to the geometry of the problem because the center of mass is symmetric. The figure look like was a lie on the wax in one specific point is something, 0. Let's compute it now and x. Again, double integral, but in this case y dy dx. So this is the same thing that we are doing before, but the only thing that changed is the integrand function. And remember, the nature of the interpretation for the double integral or triple integral depending of the nature of the integrand function. Si the integrand function is 1, well, it's a volume or it's an area. Si the integrand function is density, entonces es mass. Si the integrand function in this case is x or es y, entonces es momentum. Multiplication by the density, no? Well, the integrand function is the same. This is super easy problem. And the answer is a/15. So it's no different. Now, finally, I discovered that x hat is the ratio between ny divided by m, pero ny is 0. 0 divided by something is 0. And y hat is m x divided by m. In our case, it's a/15 divided by 4/3. The answer is 2/5. 2/5, que es 0.4 in decimal, no? So the center of mass of this lamina is located at the point 0.4, 0.0. Any question? Very good, very bad. It's easy, eh? It's another application. I want to see another point of view, no? So remember, when the one friend asks you, what do you see in calculus now? No, I see double integral and triple integral. What is the meaning of that? What is that? What information do you know? No, wait. 0,0,4. No, this is 2D. This is 2D. O sea, our problem, no, this is decimal. This is point, no comma. Okay? Or whatever. 2/5, comma 0. Uh-huh. Wait. Yes, you're right. You are right. It's completely opposite. So this is y. Let me erase everything. This is what's wrong at the beginning. A ver, es. Okay, this point is the point 0, something. Que es the y value, que es 2/5. Good? Let me try. Any question? No question? Let me try another example. Similar. No, todo bien. Okay, good. Let me try another example. In this case, I need to find mass. I need to find center of mass. Center of mass, of course, is given by two parameters, x hat and y hat. Good. Of the region in which the density function is not 1. It's 1 plus 3x plus y. This is density function. And the regions of the lamina, because two-dimensional triangular lamina, look like that. X, Y. So this is a sketch of the lamina of solid. No solid, es solid, pero you negligible the thickness. O sea, es two-dimensional problem. It's a triangle like that. And this point is 0, 0. And this point is 1, 0. And this point is 0, 1. Okay, this is our lamina. And this lamina have density. So the density in any point, is no constant, it's that function. Okay, entonces this is the function that we're using to compute the, so this is our integrand function and the mass. And in the center of mass, you need to find momentum y, momentum x, and you multiply by x or by y, and you find the momentum. And finally, you divide momentum, the corresponding momentum, by the mass, and you find the center of mass. That's it. Okay, in order to find the mass, you set out the double integral, because it's two-dimensional problem, of the integrand function, que is the density, dy dx. I like so much this orientation. So integration first like that, and extending this and this. Well, so I need to find the equation for this line, but this is super easy because you have to point. And the equation of this is y equal minus 2x plus 2. Is the equation for this line. Entonces when you integration, you go in y first, from 0 to this y, que es minus 2x plus 2. And when you extending, in dx, go from 0 to 1. And we compute the mass. I did that, the answer is A over 3. I finish my first part. Boom. To find the center of mass, I need to find the momentum. Momentum y. Where in the graph? Given the, did you make it? Yeah, of course. Yeah, it's given. So this, the geometry of the lamina is given. So it's given the density function, is given the lamina, that you want to find the center of mass and the mass. This is given. It's a triangle with the vertex 0, 0, 1, 0, and 0, 2. Okay. This is given. Okay, entonces I want the momentum, que by the way, es double integral again, but the only problem is que you multiply x times the density function. I want to integration in the same direction, Therefore, the limit is the same. And the answer of this is 1. Likewise, momentum x is double integral y 1 plus 3x plus y dy dx. The limit is the same. This is the same lamina. And the answer is 11/6. Okay, finally, x hat is equal my divided by m. Is 1 over a over 3. 3 over a, reciprocal. And y hat is x divided by m. And x is 11/6 divided by mass is a over 3. Division is 11/16. Do you plot that? I don't know. Here, center of mass, I suppose. X hat, y hat. This is a classical problem, is static. Center of mass, the one lamina. To finish the class, I want to do one more example. Here's the center of mass, but in 3D, not in 2D. This problem that we are doing now is in 2D. We are doing in 3D. Okay, any question about center of mass? It's easy, eh? Okay, it's no big deal. It's exactly the same situation, but the only thing I bring new es que the double integral no necessarily is area, no necessarily is volume, no necessarily is, depending the nature of the integral function. In this case, is density function. Entonces es a mass. Okay, this density is, is kilogram. But in this case, it's per meter square, because it's a lamina. So this lamina, I suppose that the thickness is completely negligible. It's almost zero. Or negligible, not zero, negligible. So the most important piece of the information is the area. In the 3-dimension problem, no, the density is kilogram per meter cubic, no? Because it's a solid. You need to find the center of mass of this solid. Let's see in 3D now. Suppose that I need to find the center of mass. Determine center of mass of the solid bonded by x squared plus y squared equals z, and x squared plus y squared equal z squared. And suppose that the density function is a constant and equal 10 what? Kilogram per meter cube. Okay, this is our integrand function. First of all, identification, this surface. I try to make the graph in 3D. Paraboloid, very well. Paraboloid. Paraboloid along. I need more information. Along what? Along C, very well, because C is not square. It's a paraboloid. And the second one, X squared plus Y squared equals C squared. Where's that? It's gone. Very well. Actually, we have a cone of a cone, okay, by the way, the cone is along also the z-axis, and paraboloid que is like that, which entonces our solid is in between the paraboloid bueno, no, I did that because I did in algebra, I see that this is 3D. To understand much better my solid, I am doing the sketch in 2D. For example, I'm doing the 2D lateral view. Supposedly this is the x-axis. Supposedly this is z-axis, and we have a cone. The cone look like two lines, like an actual value, and paraboloid look like and this is my solid. Okay, by the way, I need to intersecting to surface to understand, but it's easy because, for example, I know that x squared plus y squared equals z. I know that x squared plus y squared is the same, is equal to c squared. You put equal each other, those are c squared. C squared equal c. You solve this elementary equation, c squared minus c equals 0. Factorization, c minus 1. So we have two solutions, c equals 0, que is this point, and c equal 1, que is this point. So I suppose that this point is the point 1, o sea, es, I don't know, something, comma, 1. And this is something, comma, 1. This is, o sea, this level is 1, c equal 1. This is beautiful. Now this is 2D. Another 2D, sorry. Another 2D. To understand much better my solid, suppose XY, 2D. Well, entonces es a circle. It's a circle. And es obvio, substitution in either equation, in the paraboloid or in the cone, si C es 1, entonces es x squared plus y squared equal 1. It's a circle and the radius 1. It's radius 1. Okay, entonces the lateral, this is a lateral view, and this is the foreplan of this. Actually, pero no, our solid is hollow. Here, it's hollow. Okay, this is the boundary, but this is the hollow. Okay, let me see. This is complicated to see. However, in algebra, I create one script to illustrate very well this idea. Let me show you that, and after set out quickly the double integral, and that's it. Okay, let me try. Open center of mass. Okay, done. Okay, look. Let me share the screen. Okay. Do you see now, Ricardo? Do you see? Our solid. Let me see, our solid. Is formed by one cone like that, bone, and one paraboloid like that, bone, and the intersection both is this. Okay, this is the the paraboloid is the almost contact lens. Almost. So we have to walk. The outer wall is the paraboloid, look, and the inner is the cone. Okay, this is our solid. And when you compare the center of mass, okay, by the way, the center of mass is the up point. Okay, look at that. So remember the idea for the center of mass is we can suppose this mass concentrate in one point, and the point is this point. Can make sense according to the symmetry of the figure que lie on the z-axis. Make sense, right? Make sense. Okay, entonces now, in this case, I don't know why. Well, I know. I using cylindrical. I using cylindrical coordinate. Okay, using cylindrical. Why I use cylindrical? Well, we have a competition, we have a cone, and we have a paraboloid, ¿no? Y entonces I know, the professor explained me que en paraboloid we use cylindrical, but in cone we use spherical. Entonces, the answer is we can do it in both ways. However, I don't know why I prefer doing in this way. O sea, the triple integral, triple integral en cylindrical. 1, 2, 3. The integrand function is 10. Is 10. Well, I suppose que si I using cylindrical es CR theta. And C go from the C of the paraboloid to the C of the cone. C1, C2. DC. O sea, es DC. En black color. DC go to the C1, que es the C of the paraboloid, que es this. Que, by the way, is R squared. Because C is x squared plus y squared. This is R squared. To the C of the cone, que es, this is R squared again, pero this is C squared. And you apply square root both sides, es R, just R. This is the C. Okay, super. The Jacobian is R dr d theta. And R go from 0 to 1. Look at that. 0 to 1. And theta go from 0 to pi. We compute this super easy by hand. It's pi over 3. And this is the mass. In order to find momentum, in this case 3D, the momentum is momentum xy, and the formula is the same. But you're using z. So momentum xy is triple integral in the region T, but here we're using z. C density dV. Esa fórmula. Entonces es similar. Momentum es triple integral again. The limit is the same. R squared, R 0 to 1, 0 to pi. But this is C. CDC, R dr d theta. Okay, this limit is the same. And the answer is 5 pi over 6. Okay, now I know the symmetry. Okay, the center of mass. So I don't need to compute the other momentum. So don't need to compute. It's 10c. Sorry. I forgot here 10. Very well. Now, the center of mass is lie here, according to the symmetry of the figure. So I don't need to find, this is totally stupid to find another momentum xc, I suppose que es 0, a momento yc, sc. Okay, entonces the only guy que have position is c hat, que c hat is mxy divided by m. And you divide. And you divide, and you divide. And when you divide, this number divided by this number is 1/2. And the famous center of mass is the point 0,0,1/2. End the story. Okay, too much. Time is over. Okay. Let me check in quickly the attendance. Okay. Let me stop